Hey guys, sorry if you jumped on the other YouTube live. I ran into some technical difficulties, I think, with the speaker. Okay, so I didn't get any questions again for exam 3, but I'll go over a couple things in this video. So exam 3 is covering mostly chapters 7 through 9. So you'll see a couple of review questions, but it'll be mostly over chapters 7 through 9. So these next chapters these units, they're quite difficult because it does require kind of a different way of thinking. Null hypothesis testing really uses conditional probability. Um, so again, we're trying to see what's the probability that you would get a result given that your null was true. If that probability is really low, then we're going to say, okay, well, the null is probably not true. Um, But if that probability is kind of high or a little bit higher, then we could say, well, we don't have evidence to say that the null is not true. I'm not saying that the null is true. I just don't have any evidence to say that it's not true. So when you're trying to find your null hypothesis and your alternative hypothesis, you should always keep in mind that one is usually easier to find than the other, and that they're going to be the opposite from one another. So your null hypothesis is what is the status quo or what has been established in the past, whereas the alternative hypothesis tends to be what are you trying to prove. So because your alternative hypothesis is what are you trying to prove, you want to reject your null hypothesis. Okay, so like I said, we're trying to say what's the probability that we would get this result given that your null hypothesis is true. And then if it's too low, we're going to reject the null. So, how do we decide when that probability is too low? We can either look at critical values or we can look at um, the p value. So, for your critical values tells you when that's too far. So, you want to compare your critical value with the test statistic, and your critical values create your areas of rejection and your areas of non-rejection. So if your test statistic ends up being in that in the region of rejection, you're going to reject the null. If it's not, then you're not going to reject the null. Your p-value is actually just that probability of your test statistic. So in chapter 6, you calculated the probabilities of your test statistic using the table cumulative probabilities of the table, and that's essentially what your p-value is. So if your p-value is less than your alpha or your level of significance or your type 1 error rate, then you're going to reject the null. If it's greater than, then you don't reject the null. When you're doing conclusions, you want to look for these keywords. So if you reject the null, you have sufficient evidence to say that the null is not true. Whereas if you do not reject the null, you have insufficient evidence to say that the null is not true. Um, okay, if you're just joining us now and you have some questions, just let me know. You can type them in the comments below. Otherwise, I'm just going to kind of just keep going through these. So when you're looking at the conclusions on the exam, you want to first determine whether you're rejecting or not rejecting the null, um, and then look for kind of these keywords. So sufficient evidence if you're rejecting the null, and insufficient evidence if you're not rejecting the null. For both of them, it should be that the null is not true. Remember, we're using that conditional probability, so we're testing against the null. Okay, so for your type 1 error rates or your type 2 error rates, this can be tricky to interpret or to understand. Um, so knowing these rules about them can help. So type 1 error is when you decide or you say that the null is not true when in reality it is true. Whereas a type 2 error is you're saying, I don't have any evidence to say that the null is not true, or I'm not rejecting the null, but in reality, the null is actually false. So you should have rejected the null. If you are rejecting the null, you are at risk for a type 1 error. If you're not rejecting the null, then you're at risk for a type 2 error. Um, so that's another good rule of thumb to go by. If you are rejecting the null, you are not at risk for a type 2 error because type 2 error involves not rejecting the null. So if you're rejecting the null, you are at risk for a type 1 error if you're wrong. And for a type 2 error, you will commit a type 2 error if you do not reject the null and you're wrong. And then there's two instances when you can have a correct decision. So if you decide to reject the null, you're saying that the null is false when it actually is false. That's correct. Um, or if you decide not to reject the null and it is false. I mean, I'm sorry, if you decide not to reject the null and the null is actually true, then that's also a correct decision. Okay, so again, these are just some helpful rules of thumb. If you don't entirely understand the reasoning behind null hypothesis testing, that can help get you by. I don't see any questions yet. So I think what I'll do is I'll just go through some select practice exam questions that I think might be helpful to go over. And again, if you do have questions, just go ahead and post them in the comments there. All right. So let's start at 43. So this is about null hypothesis testing. So an entrepreneur is considering the purchase of an arcade. The current owner claims that over the past 5 years, the mean daily revenue was 705 with a population standard deviation of $75. We have a sample of 30 days and we have a mean revenue of 650. If you were to test the null hypothesis that the mean was 705 and decided not to reject the null, what can you conclude? So here's our decision. We're deciding not to reject the null hypothesis. We can go back to our rules of thumb. And if we are not rejecting the null, that means we have insufficient evidence to say that the null is not true. So you want to look at the ones that say we don't have enough evidence. So A says there's not enough evidence, and B says there's not enough evidence. C and D say that there is enough evidence. So we know that C and D are incorrect. So now we're trying to decide just between A and B. Remember, we're testing against the null, so we're saying that there's not enough evidence to say that the null is not true. So in this case, we have the mean value was 705 or was not 705. Our null hypothesis is that the mean value was 705. We're trying to see if that is not true. So B is the correct answer here. Okay. So definitely when you're trying to do these problems, look for that pattern. So if are you rejecting the null? That means you have sufficient evidence to say the null is not true. Are you not rejecting the null? That means you have insufficient evidence to say that the null is not true. Okay. 52. I think I'll go over 52. Okay, so the coordinator MBA program claimed that the entering class this year has a lower GMAT score than previous years. He took a sample of 50 of this year's entering students and found out their GMAT score of 550 with standard deviation of 73. This university record indicates that the GMAT score last year was 560. He wants to find out if this claim is supported at a 5% level of significance. What is a null and alternative hypothesis? So again, you want to ask yourself those questions, right? So your null is what is the status quo or what has been established in the past. and whereas your alternative is what are you trying to claim or what are you trying to prove. So in this case, he's claiming or he's trying to claim that this entering class has a lower GMAT score than previous years. So what was the GMAT score previous years? The previous GMAT scores is 560. So I'm going to say that the mean is less than 560. So the only one here that has the alternative that your mean is less than 560 is this one right here. And to get your null, you just take your opposite of your alternative. So your null is that the mean is greater than or equal to 560. Um, and that your alternative is that your mean is less than 560. So you don't want to do the 550. That's what we have for this particular year. But that's I'm not trying to prove this. I'm not trying to prove that this year we have a GMAT score that's less than 550. I'm trying to say that we have a GMAT score that is less than previous years, which was 560. Okay. So, referring to 46, which of the following describes a type 1 error? So, type 1 error, again, is when you reject the null when you really shouldn't have, right? You're saying that the null is not true when in reality it is true. Okay, so let's read all of these. So the coordinator concludes that the GMAT score of entering students is lower than previous years when it is actually not lower. So you're basically saying my claim is true, even though it really isn't. That sounds like a type 1 error to me, but let's go ahead and check the other ones. The coordinator concludes that the GMAT score of entering students is lower than previous years when it is actually lower. That sounds like a correct decision, right? So it's not B. The coordinator concludes that the mean GMAT score of entering students is not lower than previous years when it is actually not lower. So again, that seems to be a correct decision as well. And then D, the coordinator concludes that the GMAT score of entering students is not lower than previous years when it actually is lower. So D sounds like a type 2 error, right? You're saying, okay, well, I can't reject the null, or I'm not going to reject the null, but I really should have. So it looks like A is the correct answer here. We are saying the null is not true when it really is. So 53 is A. So 54 is just asking for a type 2 error. And we already concluded that D is a type 2 error. So type 2 error is you're not rejecting the null when you really should have. Okay. All right. Is there any other questions I think that someone might really want? Oh, good. Okay. Let's see. Confidence intervals. That might be something that somebody might want. So with confidence intervals, you really want to understand that the percentage or your confidence level is referring to intervals. It's not referring to your sample, but if we were to take a bunch of samples and create a confidence interval for each, then 95% of those intervals would contain the true population parameter. So that's a good kind of hint for you when you're looking at the conclusions of these confidence intervals. Are you referring to the intervals or are you referring to the sample? So if you're referring to the sample, it's probably incorrect. Let's find one of those. Um, okay, so here's number 33. So Edwin is the manager of a donut shop and is interested in estimating the mean amount its customers spend each visit. 30 customers were randomly analyzed, and Edwin produced the following interval at a 95% confidence interval. So 15.2 to 18.3. So what does this mean? Okay. Again, your confidence interval kind of gives you that leeway for an estimation. So you know that if you take a sample and you find a mean, that probably isn't the true mean of the population because of sampling error, right? So even if you were to take another sample and find a mean, it's probably going to be different than the one that you had just taken. So confidence intervals kind of account for that sampling error. And when you say that you're 95% confident that the true parameter lies between this number and this number, you can say that because theoretically, if you were to take a bunch of samples of the same sample size, infinite number of samples, and calculate a confidence interval for each of those samples, the 95% of those confidence intervals would contain the true population parameter. We just have one confidence interval. So we do have a 95% chance that we have found a confidence interval. Um, um, we do have a 95% chance that the one confidence interval that we have does contain it. Cami, I just see your question. So let me just finish this up really quick and then I'll go move on to 48. All right. So taking a look at these, if all possible samples of 30 customers are taken and confidence intervals are developed, 95% of them would include the true population mean within their interval. So, yeah, that sounds right. That's basically what a confidence interval is. 95% of sample means are between 15.21 and 18.33. Again, you want to look for 95% of intervals, right? The 95% doesn't refer to really this, that sample means will be in this particular interval. We just have this one interval that was created from our one sample, but that doesn't mean that all sample means will fall within this interval. 95% of the population means are between 15.21 and 18.3. We only have one population, true population mean, so this sentence really doesn't make sense. And the population mean will be between 15.21 and 18.33, 95% of the time. So again, this isn't exactly true because um, we're just saying that our population parameter isn't within this interval. It doesn't mean that, I mean, we could find an interval that still includes the population parameter, but is a different interval as well. So this statement is also incorrect. So A is the correct answer here. Okay, number 48. Okay, so referring to the scenario above, suppose that the test statistics fall in the region of rejection at a level of alpha level of 0.05. Which of the following is the correct decision? Okay. Let me just shrink this down here so we can see the question. All right. So referring to the scenario above. So how many toilet paper sheets should Johnson's company have on a single roll of toilet paper? So researchers determined that 1,000 sheets of paper is the mean number of sheets used during a family of four. We have a sample of 1090 sheets. Give the null and alternative hypotheses. To determine if the number of sheets during a week is greater than 1,000. Okay, so again, in order to answer this, I would like to kind of look back at what our null and alternative hypotheses are. So for alternative hypotheses, we it's what you're trying to claim. So in this case, we're trying to determine if the number of sheets is greater than 1,000. So which is the one that says that the mean is greater than 1,000? Looks like it's right here. So 47B. And you automatically know that C and D are not correct because your null and alternative hypotheses will always refer to the population rather than the sample. So the only one that says that what we're trying to claim, that the mean is greater than 1,000, is B here. Okay, so here's our null and alternative hypotheses. Suppose the test statistic falls in the region of rejection at a 0.05, which of the following is a correct decision? Well, remember that your critical values determine your regions of rejection and your regions of non-rejection. So we're not given the critical values here, but we know that there are regions of rejection and then a region of non-rejection, right? So since this is only a one-tailed test, we're only be looking at one side of the distribution. But essentially, if it falls in the region of rejection, then you're going to reject the null. I'm testing at an alpha level of 0.05, so anything that doesn't say at 0.05, we know that's not correct. So if it falls in the region of rejection, then you're going to reject the null. So 48 should be B. Well, that kind of leads us into 49 here. So if you are rejecting the null, that means you have sufficient evidence to conclude that the null is not true. So the first thing I like to do is find the ones that do say sufficient evidence. So A says not sufficient evidence, B says sufficient evidence, C says insufficient evidence, and D says sufficient evidence. So we're looking at either B or D here. And then remember, we're testing against the null. So which one says that the null is not true? B says that we have sufficient evidence to conclude the mean number is greater than 1,000, or there's sufficient evidence to conclude that the mean number of tissues is not less than or equal to 1,000. So again, we're trying to test against the null. So D would be the correct answer here. Okay. Cami, I hope that answered your question. That kind of goes back to our rules of thumb here. So if the t statistic is within the region of rejection, you're going to reject the null. If it's not within the region of rejection, you do not reject the null. I think there might be a question, I think number, like 56, for example. Let's look at 56. So if the critical value used to determine the region of rejection is negative 1.5561, and this test statistic resulted in a value of negative 1.44, we would, okay, so remember your critical region, your critical values determine your region of rejection and your region of non-rejection. So our region of rejection, or a critical value, is negative 1.54, or I'm sorry, negative 1.55661. So here's our region of rejection. And anything else in here is the non-rejection. Okay. So our test statistic resulted in a value of negative 1.4321. Oops. In here. So where is negative 1.4? Negative 1.4 somewhere in here, right? So negative 1.4. That's in our region of non-rejection. So we are not going to reject the null in this case. Okay. Are there any other questions that anybody has? There are going to be some review questions, so make sure you brush up on these ones. Oh, there is one that I think someone might have questions about. Okay, so number 46. Suppose we wish to test the null hypothesis that the mean is less than or equal to 80, and your alternative is that your mean is greater to 80. What will result if we conclude that the mean is greater than 80 when the true value is really 84? So basically, we're saying I'm rejecting this statement. This statement is probably not true, when in reality, it's not true. So that is a correct decision. But suppose this said something like this. So, what will result if we conclude that the mean is greater than 80 when the true value is really um, less than or equal to 80 or even 80? So, if we are rejecting this null when we really shouldn't have, then that's going to be a type 1 error. Okay, are there any other ones that I think someone might have questions about? This one might be a good one to go over. So number 30 says a confidence interval was used to estimate the proportion of students with hitchhiker's thumbs. A random sample of 100 students generated the following 90% confidence interval, 0.145 to 0.334. Based on this interval, the proportion of students with hitchhikers, or is the proportion of students with hitchhikers equal to 0.25? So remember that our confidence interval gives us an interval in which the true parameter could be in, or the true proportion could be in. So the true proportion of people with hitchhiker's thumb could be somewhere, anywhere between 0.145 and 0.334. So is the proportion of hitchhiker's thumb equal to 0.25? It totally could be, right? That 0.25 is within our interval there. So it's possible. So C is the correct answer. We can't say that it is for sure 0.25 though. So we can't say B. This is it. We can't say this because it could be anywhere in here, right? We're 90% confident that it's somewhere between 0.145 and 0.334. I'm not 90% confident that it's equal to 0.25. I'm 90% confident that it's somewhere within this particular interval. So we can't say that B is true. Um, if this might say, if this said something like, is the proportion of hitchhiker's thumb equal to 0.45? Then we could say no, right? So we're saying we're 90% sure that the true population parameter is somewhere within in this interval. So is it equal to 45? I'm going to say I'm 90% confident that it's not because 45% is not within this interval that we have here. Going down to this one, kind of similar. So can we conclude that oh, let me go back to see what the original, oops. Um, can we conclude that the proportion of students with hitchhiker's thumb is greater than 0.25? So again, the true population proportion could be anywhere in this. It could be 0.145, or it could be 0.334, or it could be 0.24 or 0.26. So I can't say that it's greater than 0.25. Um, it could be less than that. It could be greater than that. I can't say that it's going to be greater, though, for sure, or at least 95% confident. So again, just look at your interval and you have to say to yourself, okay, the population parameter could be anywhere in this interval. So what can I say about that? So 31 is D. I cannot conclude that the population parameter is greater than 0.25 because our interval includes values that are less than 0.25. So it could be that. Okay. Other questions? Okay, I'm going to wait a couple more minutes, see if anybody has any other questions. Otherwise, I'm going to sign off here. As always, if you guys have any questions, please email me. I'd be happy to make you guys a video or talk to on the phone or send an email, anything that you prefer. All right, guys. Well, I'm going to end it there. If you guys have any other questions, just let me know.